Hello dear children, hope you are good. I myself Praveen, mathematics tutor, I welcome you to this Sadhana school video. We have been discussing about arithmetic progressions since the 4 videos. Now I welcome you to this new video which is 5 of 8 under the heading Ganita Sampada. Dear children, hope you have books with you, a pen and a notepad to write down all the things that I am going to discuss with you. I welcome once again to this math video. Dear children, we have been discussing about the arithmetic progressions, and in that we have already discussed two important formulae. They are an is equal to a plus n minus 1 times d and Sn is equal to n by 2 times 2a plus n minus 1 times d. So based on these two formulae, we have discussed certain problems which have been given in the exercise. So let us continue with few more problems and let us try to solve few more problems from your textbook. Dear children, let me read the next question for you. Find the sum of first 40 positive integers divisible by 6. So what do you mean by this? The AP has not been given here and we need to find out the AP first and then we need to find the sum. Therefore, we have to use the SN formula in this case. So how do we start? Find the sum of the first 40 positive integers. So how does the positive integer start with? Of course, they start with plus 1, plus 2, plus 3, right? So if I start with 1, then am I right? Am I in the right side, or is my approach correct? See here, the other condition that need to be followed is the number that you consider should divide by 6. Does it apply for the first number 1? No. What about 2? Even for 2 this is no. Then what is the first number? The first number is invariably 6. Then where does this end? Does this end at 40? Since they have given 40 positive integers? Read the problem carefully, children. Find the sum of the first 40 positive integers divisible by 6. So we need to consider from 6 40 digits or 40 numbers. We need to consider 40 numbers starting from 6 which are divisible by 6 again. If 6 were to be my first number, what should be the next number which is divisible by 6 is undoubtedly 12. What about the next one? It is 18 and so on up to 40 terms. This is the mathematical form of the question which is in statement form. Find the sum of the first 40 positive integers divisible by 6 is nothing but 6, 12, 18, 6 plus 12 plus 18 plus up to 40 terms. Now let's start solving this. So this is 6 plus 12 plus 18 plus up to 40 terms. Now let us start the values of the variables. A is equal to 6. What is D? D is 12 minus 6 which is equal to 6. And then what is N? N is number of terms, that is 40. So which formula should I use here? Since I am about to find the sum, I need to use the SN formula, right? Sn is equal to n by 2 times 2a plus n minus 1 times d. Let us substitute the values. S40 is equal to 40 by 2 into 2 times, what is a here, 6 plus 40 minus 1 into d. D is also 6. So, this is 20, 2 6 are 12 plus 39 into 4. So, this can be rewritten as 12 plus, we have 39 into 6, 6 9s are 54, 5 carry, 6 3s are 18, 18 plus 5 23. So, this is 20 into 234 plus 12. What do you get? This is 6, 4, 246. So, it is 2 into 2, 4, 6 into 10 or 20 into 246. What do we get? This is 2 into 246 is 4, 9, 2 and a 0. So, the answer for the question that has been given in the statement form, we got it as 4920. So, dear children, the question can be in any form. It can be a mere mathematical statement or it can be in the English form. When the question happens to be in the English form, you need to convert that into mathematical form so that you can easily play with numbers. Dear children, hope you have noted down this problem. We shall move on to the next question. A sum of 700 is to be used to give 7 cash prizes to students of a school for their overall academic performance. If each prize is 20 less than its preceding prize, find the value of the prizes. So, we have a typical situation of the school here, wherein the school has decided to give 7 such prizes and each prize is differed from the previous one by rupees 20, and the total amount allocated for all the 7 prizes is 700. Had it been equal, then the prizes would have been 100 each. But the question is, we need to find the prize money in such a way that the difference is 20. So, how do you understand this question? Particularly when you get this question in the final examination, you need to think about 3 things. Number 1, does this question belong to AP? Does this question belong to linear equations in 2 variables? Or does this question belong to quadratic equations? These are the only 3 problematic areas wherein a question paper setter choose an application problem. Since this question has been given in the exercise of arithmetic progression chapter, it's very clear that this is an AP problem. But the problem is, this is clearly written in English and we need to translate this entire data into the mathematical form so that we have all the numbers n, d, a and an or sn, and then we can find out what is to be needed, right? So, a sum of 700, so this Sn is 700. 7 cash prizes has been given, so there are totally 7 cash prizes. And overall academic, if each prize is 20 less than the preceding prize. So, this is a catchword. There is a constant difference of minus 20 in this. Therefore, this forms the AP. Okay. If less than 20 less than the preceding prize. Suppose the first prize is 50, the second prize is 50 minus 20, that is 30. So, what would be our D? Our D would be D is equal to minus 20. So we have n is equal to 7, Sn is equal to 700 and d is equal to minus 20. What is that we need to find? We need to find the first prize A, correct? Once we get A, then subtracting 20 from each A, that is first A, we will be getting the second prize, and subsequently subtracting 20 from the second prize, we will be getting the third prize, and so on. Now let's put our efforts to find the value of A when Sn, n and d are given. So the formula used here, Sn is equal to n by 2 times 2a plus n minus 1 times d. Sn is 700. The sum of all the cash prizes is 700. What is n? N is 7 by 2 into 2a plus 7 minus 1 times minus 20. So this 700 is equal to 7 by 2 times 2a. This is 6 into minus 20 minus 120. So how do you take it up further? Then we have here 700 by 7 into 2 is equal to 2a minus 120. 2a minus 120. 7 ones are 700s are, and here we have 200 is equal to 2a minus 120, or 2a minus 120 is equal to 200, which further implies that 2a is equal to 200 plus 120, 2a is equal to 320, or a is equal to 320 by 2, that is 160. So this is the value of A. Now let us take a deep look at the prizes. What do we have here? The first prize is nothing but A, right? Second prize is 160 minus 20, that is 140. Third prize is 120. Fourth prize is 100. Fifth prize is 80. Sixth prize is 60. Seventh prize is 40. Do you think we are going to get this as 700? Now let's check out. See, 160 plus 400, this is 200, this is 200, and this is 200, and this is 100. 160 plus 40 is 200, 140 plus 60 is 200, 120 plus 80 is 200, that is 600, and plus 100 happens to be total 700. Dear children, see, this problem is a catchword where we have minus 20 being reduced or minus 20 being added, which further implies that 20 is getting reduced every time. So anything which happens simultaneously, like 20 is adding every time or 20 is getting lesser every time, then you have to think of the situation of AP. So these are some of the lifetime situations wherein the arithmetic progression concept or the arithmetic progression idea is directly applied or involved. Hope you have understood the problem and you have taken the notes of this problem. Dear children, now let's move on to the next problem. Observe this. Show that A1, A2 and up to AN form an AP where AN is defined as AN is equal to 3 plus 4n. Also find the sum of the first 15 terms in each case. A1, A2, AN forms an AP and AN is defined. AN is defined as 3 plus 4n. Now in order to continue with the problem or the data, we use formula Sn is equal to n by 2 times 2a plus n minus 1 into d, where an, a, n, d are given, or an, a, d and n are supported with a given ap. Here neither the ap is given nor the statement for ap is given, whereas in this particular problem a general form of the AP is given, wherein from that general form you need to extract the AP completely. So AN, when it is reduced or when it is drawn down to the numerical situation, we will be getting the values of AP. Now let us see how to obtain A, A1, A2, A3. Put n is equal to 1, I end up with A1 is equal to 3 plus 4 times 1, that is 3 plus 4, which is equal to 7. Now put n is equal to 2, I get A2 is equal to 3 plus 4 times 2, that is 3 plus 8, I get it as 11. Then put n is equal to 3, A3 is equal to 3 plus 4 times 3, 12 plus 3, which is equal to 15. So I have the AP 7, 11, 15 and so on. As a first step, I obtained the AP. Now let us move on to the second problem, where we need to find the sum of the first 15 terms. Now here the question is find S15 in, what is the AP 7, 11, 15. Okay children, so how do you move about? We have A is equal to 7, D is equal to 11 minus 7, that is equal to 4, N is equal to 15, S15 is equal to big question mark. So let me use the formula Sn is equal to n by 2 times 2a plus n minus 1 times d. Use n is equal to 15, S15 is equal to 15 by 2 times 2a into 2 times a, that is 7, plus 15 minus 1 into d is 4. So 15 by 2 into 14 plus 15 minus 1 is 14, 14 fours are 56, right? So this is 15 by 2 into 56 plus 14 is 70. So we get 15 into 35, 2 1s are, 2 35s are. So what is ultimately S15? You need to multiply 15 and 70, 35. 15 5s are 75, 7 carry, 15 3s are 45 plus 7, 52. So the answer is 525. The answer is 525. Dear children, now in the same way, I think you can try the second problem also. To some extent, I will help you in solving this. So here an is equal to 9 minus 5n. An is equal to 9 minus 5n. Put n is equal to 1. A1 is equal to 9 minus 5 times of 1, 9 minus 5, which is equal to 4. Then put n is equal to 2. A2 is equal to 9 minus 5 times 2, 9 minus 10, which is equal to minus 1. Put n is equal to 3. A3 is equal to 9 minus 5 times 3, that is 9 minus 15, which is equal to how much you get? Minus 6. So what is that being added or subtracted here in order to obtain the AP? Now the AP turns out to be 4 minus 1 minus 6, so on. This is the given AP. Now what is that we need to find here? We need to find S15 again. Dear children, hope you will continue with this problem and you will definitely find the solution for this. Please follow the previous problem on the similar lines. You can try this and you can obtain the solution. Now let's move on to the next problem. How many terms of the AP 24, 21, 18 must be taken so that their sum is 78? So what is that we are about to find here? There is a AP 24, 21, 18 and I am going to add them up. Then how many terms of this AP is to be taken together or added together in order to obtain 78 as the sum? What is that we need to find? Here the terms are given and we do not know to what extent we are taking the terms in order to make the 78. Therefore, the unknown is the n. We need to find the value of n when A is equal to 24, D is equal to 21 minus 24, which is equal to minus 3. So this is a star mark, because you children please take care, when you write 21 minus 24 you may end up with positive 3. It so happen that you take 21 minus 24 as 3 and you continue with further steps of the problem and you end up in dilemma or you end up in a wrong answer. Therefore be careful. Now what is that we need to find? The value of n. So which formula should I use? I should use the Sn formula just because the sum Sn is given as 78. Now let me move further. Use Sn is equal to n by 2 times 2a plus n minus 1 times d. 78 is given, n is to be found out. 2 times, what is the value of a we have got? We have got a as to be 24 and d as minus 3. Dear children, take care of the different types of brackets. We have this as parenthesis, brackets, flower bracket and the rectangular bracket. So use them in the given order. So this is 78 into 2 is equal to n times 24 2s are 48 minus 3n, minus into minus plus 3. 156 is equal to n times 48 plus 3 is 51 minus 3n, which further implies 156 is equal to 51n minus 3n square. Or when you rearrange the terms of this equation, which is quadratic. Dear children, since you have not been exposed to the quadratic formula or quadratic equations chapter, let me try to answer this question. So this, in this way I make it as 3n square minus 51n plus 156 is equal to 0 as the quadratic equation. So we have this equation and we need to solve this equation in order to obtain the roots, that is value of n. Since this is a quadratic equation, we end up with 2 roots for the given variable, which is n in this case. So let me move further. This is 3n square minus 51n plus 156 is equal to 0. Look at the coefficient and the constant. It's 3, it's 51, it's 156, which are clearly divisible by 3. Let me divide this by 3 so that I end up with small numbers so that I can easily handle the quadratic equation. So 3n square by 3 is n square, 51 by 3 is minus 17n, and 156 is 52, which is equal to 0. Now taking further, the coefficient of n square is 1 and we have 52. Let me multiply these two. 1 into 52 is 52, and I need to consider the factors of 52 in such a way that when I add them, I will be ending up with minus 17. So here it is very clear that this is 13 and 4 and minus 13 and minus 4. When you solve it, you get this as n minus 13 into n minus 4 is equal to 0, which further implies n minus 13 is equal to 0 implies n is equal to 13, and again n minus 4 is equal to 0 implies n is equal to 4.